Welcome to Algebra 2, Topic 34, Logarithm Basics and Evaluating Logarithms. So we're going to start off with some basic exponents. So if we have 2 squared, or 2 to the second power, that gives us 2 times 2, which is 4. If we move on and we have 2 cubed, or 2 to the third power, that's the same thing as 2 times 2 times 2, which is 8. But what if we're given our base and we're given our answer, but we don't know what exponent it's raised to? So we're trying to figure that out. For example, 2 to the x equals 6. We don't know what x is here. And unfortunately, it doesn't really work out to an even number that we can just think off the top of our head. That's where we use logarithms. So let's move into the definition of a logarithm with base b. So we're going to let b and y be positive numbers with b not equal to 1. So if we have the logarithm of y with base b, that is denoted by log base b of y. So b is like our subscript here and is defined as follows. So if we have log base b of y, that is equal to x, that works if and only if b to the x equals y. So notice here how we have our bases of b and b. They're both called bases. So it's the same in logarithmic form as it is in exponential form. So we would read this expression, when you're talking about logarithms to all your friends, as log base b of y. And log base b of y equaling x is equivalent, so it's the same, to b to the x equals y. So here, we're dealing with on the left, this is called logarithmic form. And on the right, we have b to the x equals y. That's exponential form. Now let's work on translating in between logarithmic form and exponential form. So if we have an example here where we have log base 2 of 8 equals 3, that's the same thing as saying 2 to the third power equals 8. So notice here we're both dealing with our base of 2. It's going to equal our exponent on the logarithmic side. And then your of y, your big number on the logarithmic side, is what it's going to equal on the exponential side. So a lot of this is just going to be practice rewriting in between logarithmic form and exponential form, because it does take some adjustment. So let's do some examples. If we have log base 4 of 1 equals 0, this is the same thing as saying 4 to the 0th power equals 1. So 4 is my base, 0 over here is my exponent, and 1 is my answer in exponential form. Now, if we're given something in exponential form and we have to rewrite it in logarithmic form, that's the same thing as saying log base 12 of 12 equals 1. Now, sometimes we're given a fraction, we're given negative exponents, that's okay. This is the same thing as saying log base 1/4 of 4 equals -1. So 1/4 raised to the -1 power equals 4. So notice here we do have to think about our properties of exponents. They come back. So let's go into some special cases with logarithmic values. The logarithm of 1. If we ever have log base b of 1 equals 0, that is because b to the 0th power equals 1. So we could have any number in our base here, raise it to the 0th power, and that will equal 1 in exponential form. So if we ever have a log base b being any number, of 1, then that is going to equal 0. And we actually see that example right up here. Now a logarithm of b with base b. So if we ever have log base b of b, that's going to equal 1. So if these values ever match, it's going to be equal to 1 because b to the 1st power equals b. And we see that right here in that example. Okay, let's move on to some examples where we can try. Let's rewrite the equation in exponential form, so it's given in logarithmic form. Here we have log base 3 of 81 equals 4. So this is the same thing. My base is 3. So 3 to the 4th power equals 81. If we want to do it in the other example, log base 7 of 7 equals 1. So here is my base, 7, raised to the 1st power is going to equal this guy here, equal 7. Okay, let's try evaluating some logarithms. So sometimes we're not given what our value would equal in the end. We have to figure it out. So we're trying to figure out what this equals. And notice this is like our answer here where it was given in the examples before. So if we want to rewrite these examples, this is saying that we have 4 to some power is going to give us 64. So what power of b gives you y? What power of 4 gives you 64? In this case, we know that this has to be 3. So we can rewrite this as log base 4 of 64 equals 3. Personally, if I ever solve some of these problems, I like to think, okay, what makes this true? 4 raised to some power gives me 64. What is that? 4 to the 3rd power. Let's move on to the next example. Log base 5 of 0.2 equals what? So if we can raise 5 to what power, that's going to give us 0.2. So 5 to what power is going to equal 0.2. Now notice here we can rewrite 0.2 as a fraction. That's personally what I would do in this case because I know some people are a little bit hesitant when it comes to fractions, but especially when dealing with exponents, it can be helpful. So we have 5 to what power equals, now 0.2 or 2/10 is the same thing as 1/5. So here, what can do that? X to the negative first power gives me 1/5. Remember those properties of exponents? So if we want to rewrite this, this is log base 5 of 2/10 gives us -1. Okay, moving on to the last example. So log base 1/5 of 125 is what? So 1/5 raised to what power gives me 125? 1/5 raised to what power gives me 125? Now here, we see the fractions. I want us to ignore the fraction right off the bat. How can we get from 5 to 125? Well, that's the same thing as 5 times 5 times 5, or 5 to the third. Now notice here, because we have a fraction, that is going to involve a negative exponent because our answer is something that's also not in a fraction. So if we're converting from fraction to a whole number, we are going to have to deal with a negative exponent. So instead of raised to the +3, this is going to be raised to the -3. So we can rewrite this as log base 1/5 of 125 equals -3. And that is part 1 of Logarithm Basics and evaluating logarithms.